I ask for that kairos moment, that those who are watching, those who are listening, would not have to die physically, but you personally in a revelation of your presence and your glory. I pray that the power of God Almighty from his throne would come down and strike each of us. And the glory of God would break through our unbelief, as we repent of our unbelief, as we repent of our self-righteousness, as we repent of those things from knowing fully, so that the generation of Joshua might go into the land, the promised land, so that.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Can you hear me?
Good evening, sir. Yes, sir.
Yes, ma'am. Yeah. Can we continue?
Yeah.
Ajay, can you hear me? Ajay.
Yes, sir. You're audible, sir.
Okay.
Sir, you're audible, sir.
Okay, sir. Okay. The last part of the topic in this chapter, alcohols, phenols, and ethers, we have to learn something called as ethers. We learned in detail alcohols and phenols, preparation, chemical properties, physical properties, and a lot of MCQs also we learned. Now the last part of the topic, maybe today and on Friday we should finish with this chapter. Now ethers. Ethers are organic compounds. Ethers are organic compounds having oxygen atom as a functional group. So molecules having our oxygen atom as a functional group will be called as ethers. So the general representation of ether will be ROR dash. R is an alkyl group, or it can be an aryl group. It is not hydrogen here. So what is this R? R can be alkyl or it can be aryl group. Similarly, R dash also can be alkyl or aryl group. Now, if R is same as R dash, then it will be called as a simple ether. Simple ether. And if R and R dash is not the same, then it's called as mixed ether. It's called as mixed ether. Now, any molecule, any organic compounds containing oxygen as a functional group will be called as ethers. So ethers are those compounds which have carbon-oxygen carbon bond. So R is an alkyl group, it is carbon, oxygen carbon bond in the structure. Where importantly, each carbon can only be a part of an alkyl group or an aryl group. I told you R can be an alkyl group or aryl group. The general representation of an ether is ROR dash. The electronegative oxygen flanked as it is by two electron pushing alkyl groups has very little tendency to participate in any reaction. What is that? Now, for an example, if you take an ether, a simple ether, now this CH3 group is an electron donating group. This CH3 group is also an electron donating group. So since electrons are moving towards oxygen, two electron pushing alkyl groups, the oxygen atom will have very less tendency to participate in any reaction because of the bulky groups across oxygen. Oxygen will not easily participate in the reaction. This lack of reactivity is also attributed to two alkyl groups enveloping the oxygen, shielding it from the reagent. Shielding it means preventing it from the reagent. So these are bulky groups. These bulky groups will prevent any reagent attacking oxygen. The ether molecule appears to have outer unreactive alkyl sheet or sphere with reactive oxygen sitting at the center. So oxygen is reactive and alkyl groups are unreactive. So this alkyl group shield or sphere, the reactive oxygen sitting in the center. Without any hydrogens directly attached to oxygen, the molecules are not capable of forming hydrogen bond. Since in ether there is no hydrogen directly bonded to oxygen, so ethers cannot form or not capable of forming hydrogen bonds. The consequence of this is that melting and boiling points are lower than the corresponding alcohols. Now, what does that mean? Now, if you take an example like the CH3O, CH3, and if you take CH3, CH2OH. Now, this is an alcohol and this is an ether. Both will have molecular formula C2H6O. The molecular formula for both the same. Now, in case of ethanol, hydrogen bonding is possible. Since hydrogen bonding is possible, the boiling point and the melting point of alcohols will be greater, higher. But in case of ether, this oxygen is shielded by these CH3 groups, big bulky groups. Therefore, oxygen cannot form hydrogen bond. Therefore, the boiling point and melting point of ethers will be always less than the boiling point and melting point of alcohols. Compatibility, solubility with water is also affected. Though smallest ether is miscible with water, any increase in size of the alkyl chain drastically lowers the ether's solubility in water and soon forms immiscible mixtures. So this is the representation of ether. Now, as the R group increases, what happens is the possibility of oxygen to form hydrogen bond with the water decreases. Therefore, solubility also decreases. Now, if R groups becomes bigger in size, this oxygen is shielded. Therefore, it will not dissolve in water. But a simplest ketone like simplest ether like dimethyl ether, this is soluble because these are not very big bulky groups. So these all are soluble in water. Low molecular mass ethers are miscible in water. But as the alkyl chain, R groups, size increases, it lowers the solubility in water. The next one is methods of preparation. Did you understand so far what I was talking about? Ether is represented RO, R dash. R and R can be same, simple ether. R and R dash different, it will be called as mixed ether. And ethers have low melting point and boiling point compared to their corresponding alcohols. All that I told you. Now, methods of preparation of ether. This is an important question. Williamson's ether synthesis. This Williamson's ether synthesis is simple. Now, an alkyl halide, for an example, we'll take a simple alkyl halide, that is methyl bromide. This alkyl halide was allowed to react with alcohol oxides, sodium or potassium alcohol oxide. What is the sodium or potassium alcohol oxide? Now, alcohol generally we represent it as ROH. This alcohol will dissociate very partially to form RO minus and H plus. It's not stable. This RO minus is called as alcohol oxide ion. This RO minus is called as alcohol oxide ion. Now, for an example, if you take C2H5OH ethanol, and this is allowed to react with sodium metal, the sodium metal will displace hydrogen. When sodium metal displaces hydrogen, we get C2H5ONA. This will be an example for sodium alkoxide. In specific, this is called as sodium ethoxide. Sodium ethoxide. Now, how do I represent sodium ethoxide? For our understanding, we'll represent sodium ethoxide like this. C2 H5ONA, I've written as NaOC2H5. Now this on heating, what happens? Na and Br gets eliminated as Na, Br. What you have now? You have CH3, you have oxygen, you have C2H5. So this is ether. It is methyl, ethyl, ether. Methyl ether, IUPAC name we will learn. This method is not applicable for tertiary alkyl halides because alkoxide ions being both powerful nucleophile and base could bring dehydrogenation of tertiary alkyl halides to form alkenes. So this method is not applicable for tertiary alkyl halides, but a simple primary alkyl halide when heated with sodium or potassium alkoxide, ethers are formed. Ethers are formed. The second reaction, did you understand this reaction? Followed?
Yes, sir.
Yeah. The second method, method of preparing an ether is by heating an alcohol with excess of concentrated sulfuric acid. Now, alcohol, ethanol, we write it like the C2H5OH. C2H5OH. Now, this alcohol, when it's heated on with concentrated sulfuric acid at 140 degrees Celsius, they mentioned, concentrated sulfuric acid is a dehydrating agent. Dehydration means removal of water. This H and OH gets eliminated as water. When H and OH gets eliminated as water, what we have C2H5, you have an oxygen here, and you have C2H5. This is an ether, C2H5. So this will be called as diethyl ether. So alcohols on dehydration, the product what we get is ether. Second method we learned. One is Williamson's ether synthesis. The other one is by heating excess alcohol with concentrated sulfuric acid. Now, from haloalkanes, this is also called as alkyl halides. Haloalkanes also called as alkyl halides. Now, when alkyl halides are heated with dry silver oxide, silver oxide. Now, ethyl iodide they have taken. We will also take the same thing, ethyl iodide. When this is heated with silver oxide, dry, it should not be moist. If it has traces of water also, hydrolysis will take place. Therefore, silver oxide should be dry. When it is heated or when it's allowed to react, what happens is these two iodine will react with this two silver to form 2AgI. Now, what is left out? You have C2H5, you have this oxygen, and you have C2H5. This is called as diethyl ether. Diethyl ether. So this is the third method of preparing. So alkyl halides, when reacted with a dry silver oxide, the product what we get is diethyl ether, or ethers we get. The next one is by the use of diazomethane to form methyl esters. Diazomethane. Azo stands for nitrogen. Di stands for two nitrogen. So methane is CH4. Now CH2, H2 we write. If these H2 is replaced by N2, then we get CH2, N2. This is called as diazomethane. This is called as diazomethane. Now, an alcohol, it's a long chain alcohol, C7H15OH, heptanol. When it's heated with diazomethane in the presence of boron trifluoride, so nitrogen gas gets eliminated and the CH2 gets bonded to hydrogen. Therefore, we get C7H15OCH3. So methyl N heptyl ether. So this is not there in the syllabus, but the other three methods are in the syllabus. So you can remember, we also can prepare by reacting an alcohol with diazomethane to form methyl ethers. What are the physical properties of ethers? Due to absence of intermolecular hydrogen bonding, the boiling point of ether is much lower than isomeric alcohols. We learned it. Now, just now I told you C2H5OH ethanol and CH3OCH3. In case of ethanol, hydrogen bonding is possible. Hydrogen bonding. But in case of dimethyl ether, no hydrogen bonding. So therefore, the boiling point and melting point of ethanol will be greater than boiling point and melting point of ethers. So we learned the reasons all in detail. Now the chemical properties we are supposed to learn. What are the chemical properties? Ethers are less reactive than compounds containing other functional groups. Why ethers are less reactive compared to other molecule containing functional group? See, these bulky groups will shield oxygen, will cover up the oxygen. So therefore, the reactant will not be in a position to attack oxygen. That is why they say ethers are less reactive than compounds containing other functional groups. They do not react with active metals like sodium or strong base like sodium hydroxide or reducing or oxidizing agent. Since this oxygen is shielded, they do not react with sodium metal or base or sodium hydroxide or reducing or oxidizing agents. Now, formation of peroxides. On standing in contact with air, ethers are overrated to unstable peroxides. Unstable peroxides. See here, this is R2O. R2O is nothing but ether, and it forms a bond with oxygen. So peroxide means more number of oxygen. Now, for an example, if you take water, there is H2O. If one more oxygen is added, H2O2, we call it as hydrogen peroxide. So a molecule containing more number of oxygen will be called as peroxide. This is ether. When it gets bonded to an oxygen atom, it will be called as peroxides. So these peroxides are unstable, which are highly explosive. These peroxides are highly explosive, even at low concentration. Hence, ether is always purified before distillation. Ether is always purified before distillation. Purification, removal of peroxides, can be done by washing ether with solution of ferrous salts. So how do we remove this peroxides? By treating this ether with ferrous salts, which reduces peroxides to alcohol, or by distillation with concentrated sulfuric acid, which oxidizes peroxide. These details is not much of importance. All right. The presence of peroxides in ether is indicated by formation of red color when ether is shaken with aqueous solution of ferrous ammonium sulfate and potassium thiocyanate. So reacting it with aqueous solution of ferrous ammonium sulfate and potassium thiocyanate. Mix it with ferrous ammonium sulfate and potassium thiocyanate, you get a red color. That red color is due to the presence of or formation of peroxides. The peroxide oxidizes ferrous to ferric ions, which react with thiocyanate to give red color, ferric thiocyanate. These reactions. In ether, if you have peroxide, when you mix it with ferrous sulfate, this ferrous ions is oxidized to ferric ions. This ferric ions, when treated with thiocyanate, we get a red color of ferric thiocyanate. However, the formation of peroxide is prevented by adding little of copper oxide to it. So ether, we can prevent the formation of peroxide by adding little amount of cuprous oxide. The basic nature. Now, ethers are basic in nature. Why ethers are basic in nature? The first reaction, owing to the presence of unshared electron pairs on oxygen. Owing to the presence of unshared electron pairs on oxygen. Now, ether, if we write ether R, I'll write here, RO, R dash, oxygen will have two lone pairs of electrons. So due to the presence of unshared electron pair on oxygen, ethers are basic. Electron pair donors are called as Lewis base, remember. So these electron pairs can be donated. Therefore, they are basic in nature, first point. Hence, they dissolve in strong acids like HCl and sulfuric acid at low temperature to form oxonium ion. So this diethyl ether which is basic in nature, it dissolves in HCl or concentrated sulfuric acid to form oxonium ion. So you get now diethyl ether with sulfuric acid gives you diethyl oxonium hydrogen sulfate. So C2H5 twice OH minus is called as diethyl oxonium. And you have HSO4, it's called as hydrogen sulfate. So this clearly proves that ether is basic in nature, because we know that H2SO4 is a very well-known acid. So a salt is formed, it means the nature of ether should be basic, because acid and base gives you salt. On account of this property, ether is removed from ethyl bromide by shaking it with concentrated only at low temperature and in strong acidic medium. On dilution, they decompose to give back original ether and acid. Ether also forms coordination complexes with Lewis acids like boron trifluoride, aluminum chloride, Grignard reagent, RMGX. This is ether. When it's allowed to react with boron trifluoride, we get R2O and boron trifluoride. This is a complex coordinate bond. So this arrow mark indicates coordinate bond. This is the proceeding of the reaction. And here this arrow mark indicates coordination bond, because both a pair of electrons is given to boron by oxygen to form a addition product. Here similarly, ether, when it's allowed to react with Grignard reagent, we get R2O, R2O. See this oxygen, 2 moles, gives you 2 pairs of electrons to magnesium. You get a complex. So the understanding is, now ether also can behave like a ligand. It also can form complexes. Now some of the chemical reactions, see, for this reason, ethers are used as solvent for Grignard reagents. So some of the chemical reactions we learn, the first one is action of ether on dilute sulfuric acid. So when ether is heated with dilute sulfuric acid under pressure, when ether is heated, now the ether is C2H5O, C2H5, that is called as diethyl ether. This ether, when you heat it with dilute sulfuric acid, see, dilute sulfuric acid means water will be in large excess, H2O. So we can write H2O as H and OH. Now if I say this bonds break here, OH attacks this C2H5 and this hydrogen attacks oxygen. Therefore, we get 2 moles of alcohol. So ethers on hydrolysis with dilute sulfuric acid, the product formed is alcohols. So when ethers are hydrolyzed with dilute sulfuric acid, dilute acids, the product, what we get is alcohols. Here in this example, it is ethanol. The next question, action of concentrated sulfuric acid. Action of concentrated sulfuric acid. When ether is heated with concentrated sulfuric acid, see, this concentrated sulfuric acid will dissociate to form HSO4, H plus and HSO4 minus. So the bonds break here. Hydrogen attacks oxygen to form ethanol. HSO4 minus attacks C2H5 to get C2H5SO4. This is called as ethyl hydrogen sulfate. Ethyl hydrogen. Just see the condition. The reaction is same. The reactants are same. But here it is dilute sulfuric acid. Here it is concentrated sulfuric acid. If we have dilute sulfuric acid, it undergoes hydrolysis. And concentrated sulfuric acid, we get a mixture of alcohol and we get ethyl hydrogen sulfate. The next reaction is action of concentrated HI or HBr. Concentrated HI or HBr. This is important. In the chapter ethers, they will ask you the reaction between ethers with HI or HBr. Now, ethyl ether with hydrogen iodide cold conditions. The first one is this, C2H5O, C2H5 with cold hydrogen iodide. With cold hydrogen iodide. What happens is the bonds break here. Hydrogen attack oxygen, iodine attack this carbon. Therefore, you get a molecule of ethanol and we get ethyl iodide, C2H5I. Here it is wrongly printed, it is a bond here, C2H5I. Similarly, you can take phenyl aromatic ring also, you get phenol and ether. This is in cold conditions. Now, some of the questions we will learn before we learn the the reaction in hot conditions. The hot conditions also, the reaction is same. We get alcohol and ethyl iodide. That is at 100 degrees. But this is important now. When ethers are heated, with excess of, important question, excess of hydrogen iodide, only alkyl iodides are formed. Only alkyl iodides are formed. Meaning, we'll take an example. If you take C2H5O, C2H5, if it is treated with excess of hydrogen iodide, so these two hydrogen and this oxygen gets eliminated as water. What you have now, C2H5, one eye attacks this group, the other eye attacks this group. So you get ethyl iodide, 2 moles of ethyl iodide. So with cold hydrogen iodide, we get a mixture of alcohol and alkyl halide. But when ethers are heated with excess of hydrogen iodide, excess means concentrated also, we can say concentrated hydrogen iodide, we get only alkyl iodides. We get only alkyl iodides. Now, some of the aromatic reactions also I have to teach you. We will learn some of the aromatic reactions now, and then we'll go to the question. Last part of the theory we have come in this chapter. Now, I will use this space because to write the reactions, I need some space. Now, few reactions, 3-4 reactions we will learn. Under that, the first reaction is halogenation. Ethers and halogenation. Pay attention to this. Students, are you there?
Yes, sir.
Yeah. Halogenation. The first one is halogenation. But just observe this. This is CH3, CH2, O, CH2, and CH3. This is nothing but diethyl ether. When diethyl ether is heated with chlorine in dark, reacted with chlorine, not heated, reacted with chlorine in dark. What happens is, we'll take 2 moles of chlorine. When we take 2 moles of chlorine, two chlorine to give 2 HCl. So what happens? 1 chlorine attacks this carbon. CH3, CHCl, O, CHCl, and you have what? CH3. So this is called as alpha comma alpha dash diethyl ether. Diethyl ether. But just observe, this is a functional group. These are called as alpha carbon atom. To differentiate, they would have marked this as alpha and they would have marked this as what? Alpha dash. So at alpha and alpha dash, we have 2 chlorine atoms. Therefore, it's called as alpha dash dichloro. And the parent molecule is diethyl ether. So this is what happens when diethyl ether is chlorinated or halogenated in dark. Now, the same reaction if we perform in the sunlight and excess of chlorine, same reaction we will perform in the presence of sunlight and excess of chlorine. We'll see what happens. This is in excess. So this is diethyl ether. When this diethyl ether is treated with excess of chlorine in the presence of sunlight. See, we have 3, 5, 7, 10 hydrogens and we have 20 chlorine. So I can write 10 and 10. So 10 chlorine plus 10 chlorine. So what happens? This 10 chlorine and this 10 hydrogen will get eliminated as 10 HCl. It's eliminated as 10 HCl. So what you have in all the hydrogen places, you get chlorine. So you get C, Cl3, C, Cl2, oxygen, C, Cl2, C, Cl3. So this will be called as perchloro diethyl ether. Peroxy means peroxide means more number of oxygen. Perchloro means more. Perchloro diethyl ether. So see the difference. These two reactions are also important, right? So halogenation is important. Ether, when it's treated with chlorine in dark, we get alpha dash dichloro diethyl ether. The same reaction when it's performed in the presence of sunlight and excess chlorine. This is excess chlorine. We get perchlorodiethyl ether. Now, one or two questions. In the last two questions we will learn, and then we'll go for the MCQs. I think we should finish the chapter today itself. So we'll start with carboxylic acids, aldehydes, ketones, and carboxylic acids in the next class. That's on Friday. Now, the next reaction is halogenation with aromatic compounds, aromatic ethers. Now, aromatic ether, the simplest aromatic ether is methoxybenzene. This is called as anisole, commonly called as anisole. So what's IUPAC name of anisole, they'll ask you. It is called as methoxybenzene. This is methoxy group and this is benzene ring, methoxy group. This methoxybenzene, this methoxy is an electron donating group. Since it is an electron donating group, it will direct the reaction to take place at ortho position and para position. So anisole, when we brominate, so I'll show ortho position here, brominate in the presence of heat and the acetic acid medium. This bromine I'll write like this. So we get H and Br. In place of this H, Br goes. So one of the product what we get is we get OCH3 and Br. So this is orthobromo anisole. Now, if we show the second molecule of anisole, if I take the second molecule of anisole, and if I show the hydrogen atom at para position, the second bromine we will write like this. So what happened? H and Br gets eliminated as HBr. So totally 2 HBr, and in place of H, bromine goes. Therefore, you have para-bromo anisole. At para position, you will get bromine. So this is para-bromo anisole. This para-bromo anisole is a major product. Why? Because bromine is a bigger atom and COCH3 is also a bigger atom. Due to the steric hindrance, this molecule will be not much of stable and the compound formed will be very, very less. Therefore, it is called as a minor product. Now, similarly, the second reaction, this is halogenation, bromination in specific, because we used bromine. Now, this next reaction, what we're going to learn is called as nitration. Same with anisole. Anisole nitration. So anisole is orthopara directing. OCH3 is electron donating group. Now, this is ortho position. When we say nitration, it is with nitrating mixture. Equal volumes of nitric acid and sulfuric acid. Nitric acid, we can write it as OH and NO2. So what happens? This H and OH gets eliminated as H2O. In place of this, NO2 goes. So we get orthonitroanisole. Orthonitroanisole. The second molecule, if I take like this, and if I show a para position, second molecule, we'll write OH and NO2. So what happens now? H and OH gets eliminated as water, and in place of that, you get OCH3, and para position, you get NO2. So you'll be para-nitroanisole. Here also the same reaction, anisole, S-O-L-E, anisole. So para-nitroanisole, this will be a major product. Similarly with Friedel-Crafts reaction, the last reaction I will write here. The third one, Friedel-Crafts reaction. F-R-I-E-D-E-L, Friedel-Crafts reaction. Now, anisole is, in anisole, the functional group, methoxy group, is orthoparadirectic. When this is heated with alkyl halide in the presence of anhydrous aluminum chloride. Remember, in Friedel-Crafts reaction, the catalyst is aluminum chloride. This H and Cl gets eliminated as HCl. In place of H, CH3 goes. Therefore, you get orthomethylanisole. Orthomethylanisole. Or it can be called as 2-methylanisole, because OCH is a functional group. 2-methylanisole. Now, if we take the second molecule, if I take the second molecule like this, we'll take the second methyl chloride molecule. So what happened? H and Cl gets eliminated as HCl. So in place of H, what goes? CH3. Therefore, you have a benzene ring. You have OCH3 and you have CH3. This is para-methylanisole, or we can write it as 1, 2, 3, and 4. 4-methylanisole. This 4-methylanisole is the major product. You know the reasons. So we have learned even the aromatic ethers. One is bromination, in general halogenation. The second one is nitration. And the third, what we have learned is Friedel-Crafts reaction. Now, whatever possible, we will learn the questions with respect to ethers. And then we are going to start with aldehydes and ketones. Now, the first question is, among the following set, next chapter, I will not continue with the questions. How much ever is possible, we will learn today, and then we'll go for the next chapter in the next class. I hope that the theory part, you have understood so much. Students, are you there?
Yes, sir.
Yeah. Now, among the following,
sir.
Among the following sets of reactants, which one produces anisole? Which one produces anisole? Acetaldehyde, Grignard reagent, phenol, sodium hydroxide, methyl iodide. See, phenol is acidic in nature. When phenol is neutralized, what happens? OH and H gets eliminated as water, and in place of OH, what goes? ONA. So therefore, we get sodium phenate, ONA. This, when you allow it to react with methyl iodide, what happens? Na and I gets eliminated as NaI, sodium iodide. In place of sodium, CH3 goes. So you get a benzene ring, O and CH3. This is called as anisole. Anisole. So the composition, which is of the reactants required to prepare anisole, or phenol, sodium hydroxide, and methyl iodide. The next question, which one is formed when sodium phenoxide is heated with ethyl iodide? Sodium phenoxide. sodium phenoxide. The sodium phenoxide, when heated with ethyl iodide, it's a similar reaction only what we learned in the previous. I and Na gets eliminated as NaI. In place of NaC2H5 goes. So you get a benzene ring, OC2H5. CH3, if you have, it's called as anisole. C2H5, it is called as phenitol. PHENETOLE. So this is chemically called as ethyl phenyl ether. It's chemically called as ethyl phenyl ether. The next question. The boiling point of thioethers are dash than those of ethers. What are thioethers? Now, if you write CH3, O, CH3, it is called as ether. Look at this. Now, if I write CH3, S, CH3, sulfur. Thio means sulfur containing compounds. So, this is called as a thioether example. Now, electronegativity of sulfur is 2.6, whereof hydrogen is 2.2. That means there isn't much dipole in the sulfur hydrogen bond. Hence, hydrogen bonding is not significant. Hence, hydrogen bonding is not significant. Now, here, oxygen is a highly electronegative element. Sulfur is not as highly electronegative element as oxygen. So here itself, now this molecule can form hydrogen bonding. Why it can form hydrogen bonding? Because these are not very big groups. As the alkyl groups increases, what happens? Hydrogen bonding is difficult. But in case of thioether, a simple thioether, hydrogen bonding is not possible. Why? Because sulfur is not as electronegative as oxygen. So therefore, the boiling point of ether will be higher than those of thioethers. So the answer for this question will be option 3. The next question, God. Ethyl chloride is converted to diethyl ether by Wood's reaction, Grignard reaction, Perkins reaction, Williamson's. So ethyl chloride is C2H5Cl. And this ethyl chloride is allowed to react with sodium ethoxide. Sodium ethoxide. NaCl gets eliminated as NaCl. And you have C2H5, O, C2H5, diethyl ether. This reaction is called as Williamson's synthesis. So the answer for this question is option 4. The next question, the 5th one. In the following sequence, the product C is. In the following sequence, the product C is. So we have to learn the reactions of aldehyde in the next chapter. But for now, you understand this. When this aldehydes are reduced, addition of hydrogen is called as reduction in the presence of palladium. When aldehydes are reduced, one hydrogen attacks this carbon, the other hydrogen attacks this oxygen. Therefore, you get CH3, CH2OH. Alcohols are formed. Aldehydes on reduction gives alcohols. Remember, this is A. This alcohols, when it's reacted with sodium, sodium displaces hydrogen. You get CH3, CH2, ONA, sodium ethoxide. This is B, sodium ethoxide. When this is allowed to react with methyl iodide, what happens? Na and I gets eliminated as NaI. What you have now? CH3, CH2, you have oxygen and CH3. This is nothing but ether. So the product form, the C here in this reaction is ether. Option 2. The next question. The value of carbon, oxygen, carbon angle in ether molecule is 180, 150, 90 degrees, 110 degrees. Please remember this. This is by memory. The oxygen bonding in ether is 110 degrees. 110 degrees. The next question. The products formed in the following reaction. The products formed in the following reactions are. What are the products formed in the following reaction? What is this? This is anisole, C6H5OCH3. So with benzene ring, they've written as C6H5. So anisole C6H5OCH3, when it's heated with hydrogen iodide, what happens? The bond between carbon and oxygen breaks. Hydrogen reacts with this oxygen and iodine reacts with the smaller group. So you get phenol and you get methyl iodide. The answer for this question is option A, option 1, that is phenol and methyl iodide. The formula of phenoxybenzene is phenoxybenzene. See, this is methoxybenzene, anisole, methoxybenzene. This is ethoxybenzene, phenethol, C2H5, we learned. Here they're asking phenoxybenzene. When you say phenoxybenzene, this is benzene, and if you have phenyl group, C6H5 group, OC6H5 group, this is called as phenoxybenzene. The answer for this is option 2, phenoxybenzene. The next question, which of the following are known as mercaptans? Thioalcohols, thioethers, thioaldehydes, thioacids. So thioalcohols are called as mercaptans. Sulfur-containing compounds are called mercapto, and thioalcohols in specific are called as mercaptans. The next question. Williamson's synthesis reaction among the following is, look at this and tell me which is Williamson's ether synthesis. Which option?
Sir, C.
Option C, yes.
C.
This is alkyl halide, sodium ethoxide gives you what? Ether. So it is option C. This is Williamson's ether synthesis. All right, option C. In the 11th question, ethers are not distilled to dryness for fear of explosion. This is due to the formation of oxides, alcohols, ethers, peroxides. Give me the answer. I taught you today in the theory classes. I taught you this today. Give me the answer. The presence of peroxides in ether is indicated by the formation. So these peroxides are what? Highly explosive peroxides. See, unstable peroxide, which are highly explosive. Even at what concentration? Low concentration. So now you tell me the answer for this question. What's the answer? Ethers are not distilled to dryness for the fear of explosion. This is due to the formation of
Peroxide.
peroxides. It's a direct question, peroxides. The next one, dialkyl sulfides. Dialkyl sulfides are called as what? Sulfenols, mercaptan, thioethers, thioesters. It's called as what? Thioethers. We learned some of the reactions. Yeah, we learned some of the reactions. I don't know, I erased it possibly, I think. It's not there. I erased, but I taught you. All right. Next question. Diethyl ether absorbs oxygen to form red-colored, sweet-smelling compound, acetic acid, ether suboxide, ether peroxide. Diethyl ether absorbs oxygen. When oxygen atom is absorbed, added, peroxides are formed. So the product formed here is ether peroxide, which is explosive. We learned it. The 14th question. The boiling is higher than dimethyl ether due to the presence of, read that and tell me the answer. Due to the presence of, I just told ether, ethanol, C2H5OH, dimethyl ether, both as
Hydrogen bonding in ethanol.
here hydrogen bonding will be there. Here no hydrogen bonding. Therefore, boiling point of ethanol is greater than diethyl ether. The answer will be option 1. The next question. Intermolecular dehydration of alcohol gives. Intermolecular dehydration of alcohol gives.
Alkenes.
Alkenes, huh? Intermolecular. Intra bere, inter bere. Intra means within the molecule. If this I'm telling you, see, this is intra. This is ethanol. This is ethanol. And when this is treated with sulfuric acid, hydrogen bonding, water gets eliminated, and you get alkenes. This is intramolecular hydrogen bonding. Intra means within the molecule. Inter means with two different molecules. When this is treated with concentrated sulfuric acid, see here also water gets eliminated, but between two different molecules. So you get C2H5, O C2H5. This is called as diethyl ether. Ethers are formed. All right, so we'll stop the class here because we have done with the chapter ethers. So in the next class, maybe on Friday, we will learn with aldehydes, ketones, and carboxylic acid. Any clarification with this chapter, you can ask me.
No, sir. No doubt, sir.
No doubts. All clear. Good. Shall we stop the class then? Friday
Sure.
we'll continue. All right. Yeah. Bye. Bye, everybody. Bye. Bye.
Thanks, sir. Bye,
Thank
sir.
you, sir.
Bye. Bye, man.